In today's lesson, we're going to investigate density. Before we can start talking about density, we need to understand what a derived unit is. A derived unit is something that we can find through a mathematical calculation. Some examples of everyday derived units that you know about and are familiar with would be speed, miles per hour. That's a derived unit. You have to compute the speed by taking the miles driven divided by the number of hours it took to drive. Area, we know length times width of an object will help us get the area of the object. Volume, length, width times height. And density also falls under the derived unit category. One derived unit equality that you must know and you need to commit to memory is that 1 milliliter of any liquid is equal to 1 centimeter cubed. This is going to become very important for us as we start investigating density. So please make sure you have written down that 1 milliliter is equal to 1 centimeter cubed. We do need to talk about the difference between mass and weight before we get to density. See, density involves a ratio of mass and volume. But before we get into how to calculate that ratio, we need to know the difference between mass and weight, and we need to know and understand what volume is. Mass is the measure of the amount of matter in an object. It is unchanging no matter where you are in the universe. Weight, on the other hand, is a measure of the gravitational force exerted on an object. Because weight is dependent upon the gravitational force on an object, a person's weight can change depending on where they are in the universe. In the diagram below, you can see a little person, and you can distinguish between that person's mass and weight based on where he or she is at in our own solar system. The Earth, the Moon, Jupiter, and the Sun all have different gravitational pull. The Moon has a gravitational pull of about 1/6 that we experience here on Earth. So while the person's mass of 63.5 kilograms does not change when they move to different places in our solar system, their weight does change. The metric measurement for weight is the Newton, which you will learn when you take physics. In parentheses below, we have the conversion for pounds. So if a person weighs 140 pounds on Earth, they only weigh 23 pounds on the Moon. The size of the person doesn't change, just the weight because of the gravitational pull. The reason that we know that the size of the person is unchanging is because the mass doesn't change, and mass is a measure of the amount of matter in an object. So the amount of matter is not going to change regardless of where you are in the universe. Before we go into calculating density, we need to first talk about volume. Volume, as you know, is the amount of space that an object occupies or takes up. For regular solids, in your math classes, you have learned that volume is equal to length times width times height, and you practiced that on a volume worksheet a couple of weeks ago. In liquids, when we're trying to measure the volume of a liquid, we learned using or through our Rainbow Lab that we use a graduated cylinder and that we measure in milliliters for liquids. But what happens when you have an irregularly shaped object? What is it that we need to use in order to calculate the volume of a liquid? We need to use something called water displacement. And the picture shows what you do. We have this irregularly shaped object right here, And we want to know how much volume that object has, but there's no way for us to measure length times width times height. So we use a large graduated cylinder that the object can fit in, and we fill it up with some liquid. So we've got some pink liquid in here. It's originally measuring 7 milliliters of liquid. We then place the object into the liquid, and we measure how much it now has in terms of the space taken up by the liquid. So we go from 7 milliliters up to 9 milliliters. The difference between the two volume readings is the volume of the object. So when you take 9 and you subtract 7 from it, you get 2. So the volume of the object is 2. Now we need to worry about a unit because we're taking a measurement. And every measurement we take must have a unit. We can't say that the object has a volume of 2 milliliters. The reason for this is because the object is a solid. So this is where it becomes extremely important for us. I'm going to make this a little bit smaller now. To remember that 1 centimeter or 1 milliliter is equal to 1 centimeter cubed. So if we displaced 2 milliliters of water, then the object has a volume of 2 centimeters cubed. Okay, so what is density? By definition, with your vocabulary, density is the ratio of an object's mass to its volume. So what exactly does that mean? Well, the term ratio literally means a division problem. So when we are thinking in terms of a ratio, we need to divide an object's mass by its volume. Mass divided by volume. In short form, it's D equals mv. How do you remember this? Well, we're very interested here as teenagers in Illinois of getting ourselves to the DMV in order to get our driver's license. That's how I always have students memorize D equals M over V. Now, because this is a division problem, we're going to have different units. Mass has units of grams and kilograms and such like that, so we've got grams. And volume has various units. If we're in solids, we're going to be using centimeters cubed. If we have a liquid, we'll use milliliters. And if we have a gas, we're going to use liters. Now you might say, Mrs. Smith, why do we have to use liters for gases instead of milliliters? And the reason for that is gases have very little mass in terms of their volume. And so we need to have our volume for gases represented as liters in order to get a high enough measurable mass for a particular gas. Now before you turn the slide, make sure you have the definition for density. Make sure you have the equation for density, and make sure you copy down the units for density. Okay, now let's take a look at example 1. Please pause the tape for a minute and copy down example 1 in your notes. Did you get it copied? Good. All right, let's take a look. Calculate the density of an object that has a volume of 42.7 centimeters cubed and a mass of 97.3 grams. Our first step is to write down the density equation again. Make sure you do this in your notes as I do this with you. So D equals M over V. Now we're given mass. Mass is 97.3 grams, and volume was given to us as 42.7 centimeters cubed. We literally just plug and chug into the equation to solve this problem. So we're going to take, let me erase that, I don't like that equal sign. We're going to take and substitute 97.3 grams divided by 42.7 centimeters cubed. When you divide this on your calculator, you're going to get 2.28 grams per centimeter cubed. Now, we have to represent the grams and the centimeters cubed because they are not the same unit. They do not cancel out. This is our second and final example for density. Please pause the tape for a minute and copy down the example in your notes. Did you get it all copied? Good. Let's take a look at the problem. Aluminum has a density of 2.7 grams per centimeters cubed. What is the volume of a sheet of aluminum foil if the mass of the sheet is 3.98 grams? This problem is different than the first problem because in this problem we're given density and we're asked to find volume. Regardless, we're going to start with our density equation. So let's copy that down. D equals M over V. Now, we can plug things in, but we're not going to be able to just chug out the answer. Let's substitute 2.70 grams per centimeters cubed for D. 2.70 grams per centimeter cubed. And that's equal to, we have a mass, 3.98 grams, but we don't know volume. What do we do? Well, I guess it depends on what you see here. Algebraically speaking, we can rearrange this equation and solve for V, or we can put 2.70 grams per centimeters cubed over 1, and we just created a proportion for ourselves. If we do that, then we can cross multiply and divide in order to get the volume. So when we cross multiply, we take 3.98 grams times 1, and we get 3.98 grams. And that is equal to 2.70 grams per centimeters cubed times V. Now what do we do to get V by itself? Correct. We divide by 2.70 grams per centimeters cubed. Now remember your algebra. You have whatever you do to one side of the equality, you have to do to the other. So now our density cancels out. We're left with V. Here on the left side, our grams cancel out, and we have to divide 3.98 by 2.7 on our calculator. I'm going to make this a little bit smaller so I have some room to write. When we divide 3.98 by 2.7 on our calculator, we get 1.47 centimeters cubed for our volume. This is how we can solve for a different variable within our equation.